Hi, in today's video we will talk about t-test and explain different aspects of t-test. And at the end of the video we will also talk about some frequently asked questions. So make sure that you watch the video right till the end. And if you like this video, please share it with others. So let's explain what t-test is. So t-test is also known as students t-test. There's another variation of t-test which is called the Welch t-test or the unequal variances t-test. In this test, we use two data populations instead of one population. So what is the goal of a t-test? So let's see, we have some data of a patient from two countries. How would you compare and see if the data is similar or significantly different from each other? One obvious answer would be that, oh, let's take the mean of the data because age is a numeric data in this case, and maybe standard deviation, and see the spread of the data and see how the mean compares to each other. But remember that the means of the two data sets can easily be influenced by outliers, which are extreme values either in one direction or the other. And so our comparison might not be very meaningful. So t-test is a better way of doing it. It's a scientific and statistically proven test, which you can use for the sake of comparison. So t-test is based on like all other tests. The t-test is based on a null hypothesis. So in this case, the null hypothesis would be that the two means which we are comparing are equal. And the alternative hypothesis would be the other way around, saying that the two means are not equal. So based on the p-value, we would either accept the null hypothesis or reject the null hypothesis. So like we said, you could use either one data sample or you could use two data samples. So with one data sample, you're comparing the mean with the arbitrary value. For example, you might have a data set which you want to compare against a national standard. So in this case, let's say that we want to compare if the mean of our data equals 8 or not. In two data samples, you compare it against each other. And then the confidence level or the confidence interval is normally it's 0.95, but you can obviously go and change it. 0.8 stands for 80% and so on. And the test could either be a one-sided t-test or a two-sided t-test. So just to demystify it, let's pose the question like this. Does the height of the boys higher than the girls in the class? So you're actually comparing on only one side of the things. So this is a one-sided t-test. A two-sided test would be when you want to compare it in both the directions, saying, does the height of the boys and girls significantly differ in a class? So you could say that the height of the boys is higher, or you could also say the height of the boys is lower compared to the girls. So it's in both the directions. And in R t-test, you can use the options called less, greater, or two-sided. And then your t-test could also be a paired t-test or an unpaired t-test. So paired t-test is when you have the data from two different cities or two different classes, and the data is not tied to one specific person. But if you think of another data set which has, let's say, the weight of a person before a treatment and after a treatment, then you will realize that the data is actually tied to a person. So the person's weight before he started the treatment and after he finished the treatment. So this is called a paired t-test. And what is the output of a t-test? Normally you get t-value, which is the critical value which shows the significance levels of the test. Degree of freedom. Normally the degree of freedom is one less of the data sample. So if your data has 100 observations, your degree of freedom would be 99. And the p level is the level of significance. Normally you set it at 0.05, which represents 95% confidence level. So just start getting into the practical side of the things. Let's prepare the data. For the data, I'm actually going to use a package called Wakefield. And if you don't have it installed, you can use this command to install it. This creates some data which has age. So in this case, I'm saying I want to create a data set which has 100 observations, and the age should be from 18 to 110. So similarly, I create another data set for females, and then I create another data set for male kids. And in this case, I'm saying the age should be between 0 and 17. Okay, so here is our data set, which we just created in this 3 commands. So the male adults age data set ranging from 18 to 110 years of age and 100 observations. Similarly, the female adults data set, and finally the male kids data set, which has the age from 0 to 17. So let's start with our t-test. And the first test which we will do would be using the 2 data samples, and which is also called Welch's t-test or unequal variances t-test. So let's get started and run our test. So if I run this command t.test, the first data set, which is the age of male adults, the second data set, which is the age of female adults, and then finally I'm saying alternative equals two-sided. So we want to compare it in both directions, lower as well as higher. And you would normally notice that depending upon your alternative, you would see that the output from the t-test, which shows an alternative hypothesis, would show true difference in means is not equal to 0. It could be lower, it could be higher, to say that it's not equal to 0. Okay, so if I run this test, here is the output. So t is 1.0523, degree of freedom is 197 or 198. And remember that we have 100 records in male adults and 100 records in female adults dataset. So, and the p-value is 0.2934. 2939. So as a rule of thumb, if the p-value is more than 0.05, then we accept the null hypothesis. If that's not the case, if it's less than 0.05, then we accept the alternative hypothesis. So once we run the test, we get this output. And with this output, we can see that t value is 1.0523, degree of freedom is 198, and p-value is 0.29339, which is higher than 0.05. In that case, we will have to accept the null hypothesis. So null hypothesis is the reverse of this one. So the true difference in means is equal to 0. And that means the two data sets are similar or significantly similar to each other. And this is the degree of, this is the confidence interval, minus 3.609 up to 11. And these are the individual means of the male adults dataset and female adults dataset. Now let's use a different alternative. So instead of alternative equals two-sided, I'm going to use alternative equals less and see the result of this one. In this case, it's actually showing you a p-value of 1. That means there's 100% chances. And it's higher than 0.05, so we will have to accept the null hypothesis. And null hypothesis is that the true difference in means is more than 0, telling us that this is higher than this is lower. Now, one sample t-test. Remember, in this case, we have 2 samples, male adults, male kids. Now we are doing a one sample t-test, and we are using just the male adults dataset. And we are comparing it against mu, or mean, equals 40. So if I run this test, this is our p-value, which is less than 0.05. What does that mean? That means we are accepting the alternative hypothesis, which is true mean is not equals to 40. And in this case, we know because the mean is actually 61, so it's not equal to 40. And this is a confidence level that 95% of the times the mean of this data set would be between this. Now, comparing exactly the same data with itself, that's just for fun. It's not going to prove anything. So in this case, we're comparing the same data with itself, which is exactly the same. So we get some extreme values in there. We get a p-value of 1. That's telling us that 100% chances that the and in this case, because p is 1, which is more than 0.05, we accept the null hypothesis. So we're going to say that the true difference in means is equal to 0. And there's 100% chances that the true difference in means is 0, which is correct. Now, let's do a equal or unequal variance option as well. So normally it assumes unequal variance. So if you go to the beginning of the introduction, we said that the Welch t-test, which is the like two samples t-test, is actually also called as unequal variances t-test. So let's run this. You can, if you want to override that variance dot equal option, you can set it to true. Default confidence interval is 95, but you can go and change it as well. Now let's go and change it by saying conf dot level equals 0.8, which is 80%. And then in the result, you get 80% confidence interval. Now, finally, there's also a t-test, which is a paired t-test. Let's prepare some data and see what the data looks like. So I'm using the library flex table just to display the data in this format. Otherwise, you don't need that. The idea is that we have some data for some people who got, for example, in class 10, the person called A got 80 marks. And then when he was in class 12, he got 92% mark. This is what I mean by a paired data set. And you can't interchange, you can't really compare 80 with somebody else's class 12 data set. But in unpaired data, it doesn't really matter. But in paired, it is important. So we have to tell the t-test that it's a paired data. And the way you do that is by telling it, saying paired equals true. This is the first series of the marks. And then this is the second series of the marks, class 12. And then giving the option paired equals true. And then two-sided, we see the results there. Now you can also save the result of the t-test into another object. So in this case, I'm saving it in dt. Once you save it in dt, you can call different variables which are available now, or columns which are available now. dt $statistics will give us the t-value. Conf dot interval would give us the low confidence interval and the high confidence interval. And this is the p-value. Similarly, if you don't like the scientific notation, you could probably use a format command and see a long string which is in a decimal format. This is the estimate or the mean, and then this is the standard error and the null value and other options. Now finally, let's answer some questions. Is t-test and students t-test different? No, t-test and student t-test is exactly the same. But a two-sample t-test is also known as Welch's t-test. What is the minimum number of records to do a reliable t-test? It's at least 10. Do you need to have the same number of records in two data sets? No, because we are dealing with mean. Your first data set, for example, in this case, the first data set could have 200 records and the second data set could have 180, and it'll still give you the reliable result because you're not comparing line by line, you're comparing just the mean. But remember, if you're using the paired data, then we have to have equal number of observations. So you can't really have one blank and other is some data in there. So how do you interpret the results of the t-test? This is just outlining the same thing again. If the p-value is less than 0.05, then we accept the alternative hypothesis. If p-value is greater than 0.05, then we accept the null hypothesis. Thank you very much for watching this video, and I'll see you in the next one.